Okay, so let's start. Last class of Numpy, what we have seen? How to generate correlational matrix. Now with one single shot, I want to generate covariance matrix and also correlation matrix. Okay. So first let me enter into this Python. First I type the code here. So what is formula for covariance? Covariance formula. X minus x bar. This is what deviation of x. Same thing, deviation of y. Mean deviation for y. Whole divided by n minus 1. So already have seen the function development for this. Once again I repeat that. Covariance. Two variables you need to pass. First left side expression x minus x bar set. X minus x dot. The right side expression. Y minus y dot mean. But xy should be numpy rs. The number of elements. You can take either x or y. X dot size. What is your expression now? L into R. This is deviation of x into deviation of y. Dot sum divided by n minus 1. Keep that n minus 1 as a separate expression. So this is the function for covariance. Already you know covariance is returning you two types of values. What are those? Three types of values: greater than 0, less than 0, or close to 0. Okay. So greater than 0 means positive, less than negative. Same thing, one more function I'm doing for correlation. Let's say x and y. First, once again, recall the formula of the correlation. Come on, tell me please. N into sigma xy. Minus sigma x into sigma y. Divided by the square root of n sigma x square minus sigma x whole square. Whole into same thing for the y. N into sigma y square minus sigma y whole square. Okay, I'm not writing that one. So for this, implementing the function. So here the formula seems to be complex. I divide them into four parts. The numerator left part, right part. Again denominator left part, right part. N is common for all the expressions here. N is number of elements. X dot size. Numerator left. N into sigma xy sir. That means n into x into y. Between numpy rs, if you apply arithmetic operation, what will happen? Element to element operation. Okay. Dot sum. Numerator right side sir. Sigma x into sigma y. That means x dot sum into y dot now entire numerator place nl minus n up to the given formula. The numerator part is ready. Do the same thing for denominator. DL left part. What is that? N. Get this. N sigma x square minus sigma x whole square. N into x double star 2. That is power line. Have all these squares sum. Dot minus x dot sum whole square. That means for sum of x whole square. Same thing for right expression. Just replace x with y. Y double star 2 dot sum minus y dot sum of whole square. Okay. So then final denominator dl into dl. For this square root we need double star 0.5. So finally we are returning the numerator divided by the denominator. Got it? Now just check these values. First importing numpy. Import numpy as np. What about that alias or alias mandatory? Is that alias np is mandatory? Not mandatory. Every time instead of saying that numpy, you are saying np. If you say x dot. That's it. Just a minute, it is running. Yeah. I'm taking some values here. One list is u. The values 1, 2, 3, 4, 5, 7. From 6 values I have given. Me, 10, 5, 7, 3, 2, 0. He, 2, 4, 7, 5, 9, 12. One more list I am giving she. Although this 9, 4.5, 8, 2.8, 1.8, and 1. In all the cases, 1, 2, 3, 4, 5, 6. Yeah. All the lists are having 4 elements. Check only the covariance. Covariance of u and me. Observe what is the result. What is the error? We did not run the. Already we have run this, right? It is expecting numpy arrays. Here all the given lists are just normal Python lists, not numpy arrays. np.array All just for checking. Now the covariance between you and me. Value is minus. Minus means what, sir? The negative relationship means what? As one variable value is increasing, second variable value decreasing. And come on, compare you and me values. How are your values? 1, 2, 3, 4, 5. Keep increasing. At the same time, my values are keep decreasing. Observe the last value, sir. 5 to 7 value increased. Again, my value got decreased. So minus 7.2, that means negative correlation. But simply the covariance is explaining you whether the relationship is positive or negative. But strong positive, weak positive, strong negative, weak negative, such kind of things it cannot explain. For this, we need to use correlation. I'm running correlation now. What is the range of correlation? Minus 1 to plus 1. Observe this. Minus 0.92. That means close to minus 1 or not. That means a strong negative relationship. Again, I want correlation between you and he. Again, you and she. Again, me, she, me, he. On that way, I want to check. There are 4 variables. That's why very less number of pairs. If there are 100 variables, for each and every pair, you cannot, first variable correlation, you cannot check with all the remaining 99, right? So that is really tougher. That's why if you build a correlation matrix, this correlation matrix will be used in so many models for in our machine learning. Especially there is a algorithm called PCA, principal compound analysis, used to reduce the dimensionality. At the time of applying the PCA algorithm, the input matrix should be either covariance or correlation. If I have 70 input variables in the given matrix, what is the size expected? 70 by 70. That is 70 rows, 70 columns. So this will be the input matrix for your eigenvalues. So in the PCA algorithm, you will be applying eigens. To compute that eigenvalues, input matrix should be either covariance or correlation matrix. Okay, now we are going to generate that one. With one single function, whatever I want, I should get it. If I need it covariance, covariance matrix. Correlation, if I pass correlation as argument, correlation matrix I should get it. So that's why here 2 arguments I will pass into the function. Observe this code, all of you. The later you can write, I will give time. Let's say C matrix is my function name. The input matrix X and the constant name I am giving. The constant, let's say like let's say types of T. The place of T I will pass I want covariance or correlation. Okay. First I am taking one empty matrix. In the given input matrix, if there are 4 columns, I am expecting 4 by 4. That means the loop should run for 4 times. First I am finding number of columns. Let's say n column. N column is x dot shape of 1. Okay. Performing main for loop. For I in range of that n call. Think that there are 4, n call value is 4. Range of 4 means what, sir? 0 to 3. In the first iteration, 0. But what we are expecting, the 0 has to be correlated with 0 to 0, 0 to 1, 0 to 2, 0 to 3. One more for loop within the internal, I will write it. Here I am taking one empty list. Within that list, the correlation of 0 to 1, 0 to 2, 0 to 0, 0 to 1, 2, 3, I will keep. Okay. One more for loop here. For I in range of and how. Now total loop runs for how many times, sir? If I give some statement here, the statement executed how many times now? 16 times. Observe. For each value of I, the second for loop is running for, okay, here let's say j. For each value of I, j moves from 0 to 3 or not? I moves from 0 to 3. For each of I, value of I, j moves from 0 to 3. That means 4 into 4, 16 times. But here what I need is, depends on what you want. If T is equal to COV, I need covariance matrix. Else, I need correlation matrix. Understand the points? If T is equal to COV, how to find the covariance? COV of column 1 comma column 2, sir. How to take the first column? What is your matrix? X. All rows, I column. In the first iteration of main for loop, what is I value? 0. X of all rows, comma z. What is the z value now? 0. That means 0 column, 0 column. In the second iteration of second for loop, 0 column, j value 1. That means first column will be correlated with second column. Like this we are taking. This thing we are appending to m dot append of this one. Right? For example, given condition false. That means that is a correlation you want. Same thing, m dot append of COV of x of, sorry, COR, correlation of all rows, I column, x of all rows, j column. Got this? After completion of this for loop, your m is ready. Whether it is a correlation or covariance. This m value I am appending to main matrix, cm dot append. Append off. Yeah. But cm is a normal list. We need numpy array. Final return np dot. np dot array of cm. That's it. Got it? Now observe this code. Where? Where color? Yeah, and for loop. Follow set right? Just try to execute this. Luckily, no code errors. I'm preparing a matrix, input matrix now. Let's say the matrix is M, capital M. np dot c underscore. What are the things we have? You, me, he, she. Every list is a single dimension here. So that 4 columns you will get. How many number of rows? There are 6 rows, 6 elements, 6 rows. That means the number of rows is number of elements in the dimension. Okay? Each single dimension has a separate column. Understand? Now check the shape of it. M dot shape. Six rows, 4 columns. Check all the values, please. I have 4 columns. What matrix you are expecting? 4 by 4 you are expecting. 4 by 4 covariance matrix or 4 by 4 correlation matrix. Now I am going to call it. What is the function name, sir? Have you C matrix. C matrix of M is my input. I want covariance. Passing COV as argument. Run. Check these values, please. This is the covariance value. Pass other thing. Other than COV, anything it will take it. I am passing COR. I should get correlation matrix. Look at the diagonals. 0 to 0, 1. Again, 1 to 1, 2 to 2, 3 to 3. For all the things, 1. What is your comment on this? Correlation between she and he. Correlation between she and he. The comment, please. Correlation between he and me. The second column is he, right? What we have given. This is correlation between me and you. Like that. It doesn't matter how many columns are there. If there are 100 columns, 100 by 100 matrix you will get. On top of this one, you will apply in future in different models, eigenvalues, eigenvectors we will apply on this one. Understand the point, sir? But I am passing not COR, I am passing ABCD. Still it is giving me correlation because we did not fix any rule in the program. But I want it should accept only two keywords, COV, COR. Just do small modification here. Elif. Elif means in Python, else and if. T equals to COR. Then this should happen. Still else. Sorry. Just print some error message. Wrong one. Just check this one. I'm running this entire code once again. Now pass some wrong argument value. C matrix of M. M is your input matrix. Some ABC. Printing wrong argument for each iteration. Then do some more modification. Because this is kept into for loop, right? Arguments. Immediately next onwards, the iteration should not proceed, sir. Just break it. Now running the same thing. That is what loop is break it, sir. Inner loop is break, not upper loop break. Understand the point, sir? Here only check it. If T is equal to, if T, one more technique, not in, not in list of, not in list of COV or COR. Add arguments. Now I am passing ABC. ABC not in COV and COR. Correct or not? True or false? Hmm? True. Because of true, wrong message, and then it will break it out. Then you can remove this here. Now run with same ABC. Okay? Like this. Come on, take this code. Already have taken the code for covariance in last class. And also correlation also have taken. Take this latest code. Please take care of brackets. Just 1 minute, sir. Here we will add this. E not in. Please add this. Then break it. completed all of you?